Hello and welcome everyone. Thanks for joining us for this O'Reilly Media Live course. I'm Brittany Brady and I will be your facilitator for the course. We're excited to have you here. We'll be kicking things off shortly, but before we dive into the content, I'd like to go over a few quick housekeeping notes to help you get the most out of today's session. At the top right corner of your screen, you'll see a set of widgets. The two we'll be using the most today are the Q&A and attendee chat. Feel free to open those up now if they did not open automatically when you joined. We encourage you to jump into the chat and be part of the conversation. This session is being recorded, including any participation from attendees. So if you take part in the chat or Q&A, please do not post personal information like your email address, because that'll be included in the recording. You'll receive an email within the next 24 to 48 hours with a link to the session recording, so you can review or catch up on anything you missed. Please note that the chat feature should not be used if you're subject to regulated communication restrictions. Also, keep in mind that others in the audience today may include fellow professionals, vendors, or even competitors. We hope you take advantage of the interactive tools. Please be cautious about what you choose to share. I'm going to hand things over to Benjamin now to kick off today's course. And with that, let's get started.
All right, thank you so much for the kind introduction. Welcome everyone to the new year. And today's course will be talking about the Certified Kubernetes Application Developer certification, one of those certifications in the landscape of Kubernetes certifications that you may be looking into acing in the new year. Just as a heads up, there are other certifications that we also provide on the O'Reilly platform. So if that's something that you're interested in, definitely check out the dates. Sometimes it does come up as one of the questions where attendees not only want to take the CKAD certification, but potentially they may also want to transition over to the CKA certification or any of the other more advanced certifications as well. So we usually provide them on the platform, so definitely check that out. So what are we going to do here today and the next 2 days? We are going to try to talk about the whole curriculum that is relevant for the CKAD certification. And that not only includes the theory, but also the hands-on exercises that are prepared for this course. So once the time comes, I will potentially give you a chance to play around with Kubernetes in more detail. I will try to challenge you as much as possible because, as you know, the CKAD certification is a completely hands-on certification. So you will need to have that knowledge in your tool belt. Otherwise, there's, I would say, almost zero chance that you will pass the certification once you actually sign up for the test itself. A couple of words about the logistics for this course. So we'll have roughly a 5-minute break every hour or so. I will try not to rush it. We have 3 different days here. So overall 12 hours. Sounds like a lot, but you will see as we go through the curriculum and specifically individual topics, there's a lot to learn and a lot to understand. So therefore, we definitely want to make sure that we spend as much time as possible on the meat of the presentation. In fact, I will spend about 30 minutes or so on the general outline of the certification. So what kind of topics are we going to talk about? What is going to be relevant for the certification? How does the environment look like? How do I sign up? And those kinds of things. So those are definitely topics that I want to touch on here in the first place. All right, so let me do the following. Before we begin with my slide deck, I always try to loosen things up a little bit. So what I'm going to push here is a little poll where I would like to fill out the room. So where do you stand with your Kubernetes knowledge? So if you wouldn't mind picking one of those options, there's no right or wrong answer for this one. And don't be shy if you're just a beginner to Kubernetes. I actually took this certification when I was a beginner to Kubernetes itself. And that gave me plenty of exposure to the Kubernetes ecosystem and what you need to understand for Kubernetes in general. So I see we have 10, 15 folks that have selected one of those options already. We'll probably give it 15 more seconds or so, or 20 more seconds. I know it's the new year, probably your first workday back after a long break. So definitely everybody's kind of tired and sluggish. to be expected for this course, but hopefully we can make it as exciting as possible. So I'll give it maybe 10 more seconds and then we'll jump into the results here. See, everybody's filling out the form for the most part. That's awesome. That's good to see. And by the way, as Brittany mentioned, we'll also have a recording in place, which we'll send out after this course. So if you can't commit to all of those days in this course, we will definitely send you over the recording of the other days. Or if you want to go back, have a look at the recording again, because you may not have understood something going through the materials. That's definitely possible as well. All right, so let me push that to you and see where we stand here. So we have about 45% of attendees that are beginners to Kubernetes. Then we have intermediate folks here and some advanced users. So the results here are definitely more mixed than what I usually see here. Oftentimes for the CKAD, I see more beginners attending for this course. And in this case, we almost have a somewhat equal distribution. I'd say more beginners and intermediate, of course, than advanced, because I would say the CKAD certification is definitely not necessarily an advanced course. So somebody's saying here, hello from Poland. Hello from my end. Thanks for joining today. And here's one more question. Are the recordings sent out on a daily basis? I believe they are, but for that, I would have to give it back to Brittany because I'm usually not in charge of sending this out or managing the recordings, but I believe they're likely being sent out after each of those days. Here's one more question. According to the agenda for day 1, it's about 6 hours and 2 hours for day 2 and 3. However, the actual schedule is 4 hours each day. Not quite sure where you got the 6 hours from. The first day, or today, is going to be 4 hours, and the following days will be 4 hours as well. We usually don't run any courses longer than 4 hours per day, simply because the attention span simply sharply drops off, and the same goes for the trainer. It's really hard to run a training for more than half a day or so. So that's what we got here. And if that is still not clear, I will definitely be able to give you more information from through Brittany if that's something that you're interested in. But generally speaking, we have 3 days, each 4 hours. So here's one more comment question. I've used Kubernetes for 8+ years. Awesome. But I am more of a lower intermediate because I do not use Kubernetes much. And it has not yet been adopted much at work. That's completely fine. You will actually see how Kubernetes can be used from the application developer's perspective. If you had a chance to compare the CK and the CKAD certification, you will actually see that there's quite a bit of overlap in the topics. So if you plan to look at it from different perspectives, and I would usually suggest to go with the kind of certification in the first place that reflects your current role in the organization. So if you're more of a sysadmin, you may want to go for the CKA certification. If you're more of an application developer or engineer in that sense, I would probably go with the CKAD certification, but it kind of depends on your preference. And some attendees actually do prefer to take both certifications. I've taken both of them, and it's really nice to see different perspectives on different aspects of Kubernetes, even though you may not handle them on a day-to-day basis. It definitely broadens your exposure to Kubernetes in general. And that is something that we definitely want to strive for. All right, awesome. So I will go ahead and will share my screen. This will only take a couple of seconds. So I'll make sure that I share my full screen here. Should be coming up here. And what you can see here is my title slide. So the title slide is based on the curriculum that was published in May 2024. In the meantime, there has not been a significant update to the outline. So that means all the topics are still the same as in 2024. What I've seen in the past is that the curriculum likely will change every 3 years or so, where there's usually a more drastic change. Potentially, they will take out some topics, will add new ones in. We've actually recently seen a change to the CKAD certification, where they, for example, added the new gateway API, which I would assume will likely become part of the CKAD certification as well, because it's simply going to replace the Ingress API or Ingress resource in Kubernetes long term. So probably that's going to be one of the bigger changes that will come up. But if that's a topic that you're interested in, that you would like to learn more about, definitely also feel free to check out the certification course materials for the CKAD certification, which you can find in my GitHub repository. Talking about my GitHub repository, so let's briefly talk about that. You can find the URL for this GitHub repository that contains not only the slide deck in PDF form, but also all the exercises in this GitHub repository. So you can see here slides.pdf is the one that I usually update going forward. And then underneath the exercises folder, you will actually see different kinds of exercises that we potentially want to go through, but you can also use many of them as a homework or something that you can go through at a later point of time. Now you can see here we have 32 different exercises. That's quite a bit. We'll probably not be able to go through all of them, but in the end, I will want to give you exposure to different aspects of Kubernetes, even though we may be running out of time here and there. So you can definitely go back to this as a homework. So just to show you one example here, we have one exercise on Helm and how to build your own chart. Just as a heads up, this is actually more of a exercise that you don't have to be familiar with. It's actually out of scope for the CKAD certification, but I still want to give you additional exposure to aspects that may be important. Just to give you the impression how this actually looks like, there's usually a quick reference up here. So you may know that in the test for the CKAD, you are allowed to use the official Kubernetes documentation and the Helm documentation. So therefore, you can find similar links up here. Then down here, you will find some important notes and potentially a link to a O'Reilly interactive lab. So if you click on this one, this will bring you to a interactive lab that lets you bring up the Kubernetes environment in an I'll figure that out afterwards, but I will show that to you at a later given point of time. Apparently, I need to use a different login. So let me quickly see if I can make this work here. Unfortunately, it logs me out every so often. So it must have been this one. But you can see here, that is a interactive lab on the O'Reilly platform. If you are a subscriber to the O'Reilly platform, you will be able to simply click the start button, and this will automatically bring up a Kubernetes cluster with the right setup. So you can go through individual steps that somewhat look like what you will find in the CKAD test and test environment. So that's going to be exciting. If you don't have Kubernetes set up for whatever reason on your local machine, or certain components are not installed, for example, a ingress or network policy controller, this is a good starting point that lets you play around with things. You cannot really break anything in this lab, so therefore it's really a safe environment for you to play around with different commands and to be able to delete objects and things like that. So definitely recommended and suggested from my end. So I'm going to close this one here. And then one more side note here for all of the exercises, if you want to go back to them, there's a solution folder, which not only includes a solution.md file, so a markdown file that has a textual description of the solution, but then also a couple of files that are relevant for solving that specific problem. So for example, here, we're trying to build a Helm chart, so therefore we need to have the relevant Helm files in YAML form. For other exercises, it will simply include other files. And then just coming back up here, you will find a list of resources that you may find helpful. Don't necessarily just want to give you an exposure to what I personally offer on the O'Reilly platform, but there are definitely other learning resources that you may want to tap into. So for example, there is a course on the CKAD from Code Cloud, if that's something that you prefer. But most importantly, there's also the different simulators and community provided scenarios on Killer Coda, which are super useful if you want to get additional exposure. They may be similar to mine, but they will basically have simulated environments similar to what I've been showing to you. So here is a question. How do we access the O'Reilly platform? Oh, playground, never mind. One way to do it, if you just want to have Kubernetes, and just be aware that the Kubernetes environment will only provide to you a sandbox environment with the specific version of Kubernetes. The playlist that I just posted here in the attendees chat will have specific aspects that walks you through that. If you just want to go for the sandbox, you can type in up here Kubernetes sandbox, and that will probably just get you directly to that sandbox. So if you don't want any description around what I've shown to you, that is how you can go there. So I'm just going to copy paste it right here. And that is simply just a plain old sandbox environment, including a Visual Studio Code editor, which you wouldn't have in the certification environment. But once you're starting to get more familiar with Kubernetes, it may be a good way to get more familiar here. So let's see if there was any other question. So I posted the link to the O'Reilly Playground and the O'Reilly Lab, so you should have everything in place. I'm going to close this one here in the meantime. We don't really need that anymore. One more thing to mention here, if you're new to the certifications and you want to ask additional questions on any of the Kubernetes certifications, there is in fact a Kubernetes Slack channel called Certifications, and that is being run by the CNCF Foundation / Linux Foundation. That is definitely something that you will want to check out. Also, if you run into trouble with your test environment for whatever reason, you want to retake the certification and you have a question about it, that is definitely a good place to ask any questions about it. All right, so here's a question. Is this course similar as the O'Reilly Verifiable Skills for Kubernetes? I see the same slides. Some of the videos that have been published to the verifiable skills for Kubernetes are based on videos I recorded. There are other videos, and I wasn't deeply involved as a side note in that project. Many of those videos have also been provided by other trainers, as far as I know. So I wouldn't necessarily say they're exactly the same, but some of the videos have been taken from my video course for the CKAD. So that's for sure. So if that's something you already watched before, you can take this live course to ask additional questions or try things out hands-on. If you do prefer a video-based course, that may be your better option. And here's one more question. Let me quickly parse this here. Worthwhile having a look at the page. Here's day 1 as 30 minutes, then 120 minutes. Okay, interesting. Thank you for pointing me to this one. I will definitely send that out over to the production folks here. I think that's actually a mistake because every day is usually 4 hours. So maybe they had a typo in there. Not quite sure why they changed that, but I will definitely check in with them. But thank you for providing me with this link here specifically. So that should likely be corrected here. I will definitely check this out after we're done with this course for today. All right, and then here's one more folder on prerequisites. You may have noticed that I mentioned Minikube as my Kubernetes local development environment. It's not the only environment that you can use for playing around with Kubernetes. You can use Kind if that's something that you want to use, or K3s. All of those options are completely valid. They will likely not deviate too much in terms of the runtime behavior. But what I'm going to demonstrate here is going to be based on Minikube, which I installed on my local machine. And obviously, given that we have to run kube control quite a bit in the exam environment, we will want to use kube control in more detail. Kube control completely decoupled, and it's a different executable than your Kubernetes cluster, which needs to be installed on your local machine as well. So I would suggest to install that, because we'll run kube control over and over again. You may have noticed that I'm going to use Docker Desktop here, because I'm going to be on Mac here on my machine. You can simply just use Docker Engine if that's something that you already installed on Linux, for example. So it kind of depends on your local setup on your local machine. So check that out and definitely try to get that functional. If you can't, you can definitely always fall back to the O'Reilly Interactive Labs if that's something that you prefer. If you don't want to set anything up, but long term, if you're trying to use Kubernetes at work anyway, it may make sense to actually play around with those target environments a bit more. All right, so that's what I got here in the GitHub repository. I just mentioned there's also a course on the CKA certification. And let me give you the link to that one for anyone that may potentially be interested in the Gateway API that is covered here in this course. And you can find that directly in those slides. By the way, this is the slide deck for the course that are run on the CKA as well. Here's a question. Is kube control also running on the cluster? Because when I try to do a PS command, I do see kube control running on the cluster. It kind of depends on your Kubernetes environment. For the most part, it's likely going to be pre-installed. And by the way, it's going to be pre-installed, of course, in the exam environment. But if you are dealing with a different kind of cluster, it may already be installed on individual host machines that represent the nodes of your Kubernetes cluster. So you can have kube control on your local developer machine, of course, because imagine you are trying to talk to a Kubernetes cluster in the cloud, say on AWS, then there you will likely want to run it from your local machine or through the dashboard, which we will not have available, by the way, in the exam environment. Or let's say you have a local installation of a Kubernetes cluster, then the host machine will likely be the same one as your Kubernetes cluster, or it may be running in a virtual machine. So it kind of depends on your setup, but it's definitely possible that kube control could be available in your target environment. And that includes the host machines of your Kubernetes cluster. All right. Any more questions before we jump into the slide deck? And as I mentioned before, first thing we want to talk about is the actual exam itself. So any questions on the exams can be addressed in the first portion of this course. And while I'm waiting for additional questions, here are just a couple of more links and URLs or profile handles if you want to reach out to me. Offer from my end, if anything comes up after the course or between sessions, feel free to send me an email. Happy to respond to your questions on the exam. And you can definitely find all my course materials on GitHub under my handle bmushko. Then if you want to connect with me on LinkedIn, definitely feel free to share your successes once you pass the certification. Happy to cheer you on. And you can definitely find me there as well. Automated Ascent, that's my company name. So if you want to check that out, feel free to go to the URL. But I won't really talk about that in more detail. But really my background is in that space. Cloud migrations, project automation that includes CI/CD, build tools, and also big refactorings, mass refactorings is something that I work on these days quite a bit. All right, so let's jump right in and talk about the exam objectives. And before we do so, specifically on the CKAD, want to give you a high-level overview on the existing Kubernetes certifications that are in place right now. If you attended KubeCon I believe in November last year, you may have seen that they will add 2 more Kubernetes certifications to this mix, which I have not added to my slide here. I have personally not taken the new certifications myself, but I may be checking them out. If that's something that you're interested in, for example, as part of a course on the O'Reilly platform, do let us know in the survey form after the course. And that would be definitely exciting for us to understand if that's something that you would consider. For example, the network engineer for Kubernetes, that is one of the new certifications that just came out. But let me talk about the ones that we used to have for the past, I would say, 3 years or so. And I tried to group them a little bit by the knowledge level that you need to have, and then also the kind of role that you have within a company or organization. And the first ones that I want to talk about here are the entry-level associate certifications. Those are certifications good for anyone that kind of wants to break into the field of cloud providers, cloud environments, and also wants to get a first taste of Kubernetes itself. For those kinds of folks, if that's your background, I would suggest to take the Kubernetes and Cloud Native Associate certification. That's definitely a certification that you can pass without too much deep knowledge on Kubernetes or hands-on knowledge on Kubernetes. Because the certification itself is based on multiple choice questions. You don't actually have to run kube control or interact with the real Kubernetes cluster. And therefore, if you kind of feel like you're somewhat new to Kubernetes, you don't know where you're fitting in, this may be a fairly good option for you. Then on the right side of this certification, we can see the Kubernetes and Cloud Native Security Associate. Even though I grouped this in the entry-level certification, I would say it's definitely a more advanced Kubernetes certification, simply because it requires quite a bit of knowledge of Kubernetes. And not only that, it basically asks you broad questions on security in general. I personally thought it was not the easiest to pass. And in fact, it was the last Kubernetes certification that I passed of all of those that you see here. So therefore, I would say it's definitely not necessarily beginner level, but if you do have some background in security, specifically in that topic, in that domain, then it may be easier for you to pass. But for me, it was not that easy. And I think it requires broad knowledge of security topics in general. Now, that one is also a multiple choice question based certification. And this is very different from the ones that we are going to talk about here in this course, which are the hands-on practitioner certifications. They're meant for folks that already use Kubernetes, or at least use Kubernetes using kube control or dashboard, kind of doesn't matter, but you want to prove your knowledge of Kubernetes from the perspective of likely the role that you're in right now or the role that you want to transition into. And you can see here developer and administrator are separated a little bit. You can see that we are going to talk about the CKAD certification today and the following 2 days. But if you like that kind of style of certification, but you want to get more exposure to the sysadmin side of things for Kubernetes, then I can suggest to you the Certified Kubernetes Administrator. And then as the next logical step, I would say almost, you can also go for the Security Specialist certification, which is likely of all of those 5 certifications, the most complex and hard to pass certification, because not only does it bring Kubernetes into the mix, but it also adds external tooling that is part of the CNCF landscape. So for example, it's going to be bringing in like Trivy and other external open source tools for the most part. But I found this to be a very interesting certification because nowadays we're not just developers, we're not just admins, but security is really a concern that we need to deal on a day-to-day basis, independent of the role that we're in. So today we are going to talk about the CKAD certification, which is a completely hands-on certification. Can't mention this enough. So if you only have theoretical knowledge about Kubernetes, you will probably not be able to pass the certification by just sitting in the training today and then taking the test afterwards, because for the most part, you will have to use kube control quite a bit. And as I mentioned before, kube control is your basically primary client that you will want to use, at least for the purpose of passing the certification, because no visual dashboard is going to be available. So if you're more used to cloud provider environments, you will want to change your mindset a little bit, which is unfortunate. I would think you should be allowed to use a visual dashboard because it's just what you use on a day-to-day basis. You may not be using kube control all the time, but that is not what the Linux Foundation settled on. And they decided that you have to solve pretty much all of the problems using kube control. So everything is going to be command line based, but at least from the perspective of using kube control, you can use the imperative or the declarative approach. Doesn't matter how you solve that problem, you can get to your goal with either path, and they will grade based on the end result, not based on the approach that you've been taken. All right, so we will focus primarily on Kubernetes features and aspects that are going to be relevant for application developers, and that means we will look into the process of designing, building, configuring, and exposing cloud-native applications for Kubernetes. You will probably know that the Kubernetes certifications will not be cloud provider-based or cloud provider-specific. So therefore, that's completely out of question. All we are going to talk about in this course is Kubernetes on-premises. So basically a installation that we're dealing with that is not necessarily running in the cloud provider. All right, so what are the topics for the certification? There are 5 high-level, what they call domains. So effectively, a domain is a high-level topic, which will then break down in more detail. You can see each of those domains contribute to the total score. And I would say for the CKAD certification, that's pretty evenly distributed. So like mostly 20% buckets here. So you have to get some good exposure to each of those topics to be able to arrive at the total score, which I believe was 69%, if I remember correctly. It may have changed in the meantime. That is why I usually don't put that into my materials and things like that, because over time, that number may simply change. So let's break it down into those domains. You can see here that there are these 5 domains, and each of those domains contain relevant topics for that domain. So for example, in application design and build, we will want to understand how to define, build, and modify container images. So that is really independent already of Kubernetes itself. So they want you to be familiar with the process of creating a container image from scratch, from a container file. And that is definitely also something we'll want to explore, at least in exercise number 1. It's a little bit out of scope for Kubernetes itself, but if you think about the process of being a developer and producing like a container image for the application you want to run in Kubernetes, then this makes complete sense. Then we will want to talk about pods in general, basically the Kubernetes primitive that lets you run workload. And there are different ways how we can run workloads. Unfortunately, I don't think they still haven't corrected this, where they say here, as one of the bold statement here in parentheses, development, daemon set, cron job, and so on. I believe they meant to say here deployment and not development. I'm not quite sure what they mean by that, because that's not a workload resource in that sense. So we'll definitely talk about the pod concept with running one container inside of it. But then we'll also explore some use cases where multiple containers running in the same pod may make sense. In this domain, we will also briefly talk about volumes, and we'll compare the ephemeral volume types with the persistent volume types and how to set them up in your Kubernetes cluster. Then we'll go a little bit deeper into application deployment. That means we'll bring in the more advanced Kubernetes resource called the deployment, which for the most part you will likely use in 99% of the cases anyway, instead of just a plain vanilla pod. Here we will want to start with a deployment, which lets us basically scale the number of replicas, so the identical copies of pods we want to run applications inside. And with the help of the deployment, we have far more options. Not only does it help us with basically defining the number of those replicas, but also we will be able to easily roll out changes to those replicas using the deployment primitive. We will talk about different deployment strategies in this domain, which includes the ones that come with the deployment primitive, but also some that are not, I would say, directly supported by core Kubernetes. There are definitely some external open source tools and projects that can help you with that in more detail. I will mention them, but they're not going to be part of the certification. So for example, in this context of blue-green or canary deployment strategies, you may have heard that people use Flux or Argo rollouts. That is out of scope for the certification, but if you want to go further, there are definitely dedicated certifications in that realm as well. And as you can see here, they also want you to understand the open source tools called Helm and Customize, which will let you deploy either external packages created by somebody else, or that lets you install an operator, or that lets you basically bundle up your own application resources, or at least definitions of it, in the form of YAML files, and then lets you customize them upon basically deploying them to the Kubernetes cluster in more detail. Then we'll transition over to application observability and maintenance. This domain will all be about troubleshooting issues that may arise in production as soon as you actually deploy your application to Kubernetes. We all know that there's likely not going to be just a happy path in Kubernetes or really with any software development at all. And therefore, we want to equip ourselves with techniques that let us identify underlying issues by running corresponding kube control commands. We will want to identify that issue and then fix it, of course. And within that realm, there are some other topics that I want to bring in here. For example, the health probes that we can add to containers running inside of a Kubernetes pod. And we will also want to understand how to deal with deprecations of the Kubernetes API once we are ready to upgrade to the next Kubernetes version, and how to handle that when you work together with your Kubernetes administrator. Then we will transition over to application environment configuration and security. That's somewhat of a, I would almost call it a catch-all bucket. This is pretty much a domain where I think they didn't know exactly how to group it. I would probably have broken it down in more into smaller domains if I could have, but they decided to put it all into one bigger bucket here. And as you can see here, this will deal with operators. It will deal with what happens when you run a kube control command and send a command to the API server of the Kubernetes cluster, which includes authentication, authorization, and admission control. We will learn about resource management on the container level, and then we'll also learn about some of the Kubernetes primitives that let us constrain or govern the consumption of certain resources. We will learn how to define configuration data and how to make it available to you running applications inside of the container. And then lastly, we will also have some security-specific features that we want to bring in, more specifically, the security context. which is definitely configurable for a pod in Kubernetes. And then lastly, but not less important, actually almost more important, I would say, is the topic on services and networking. And here we will touch on the often misunderstood Kubernetes primitive, the service, at least by beginners. So we will want to learn more about that, the different kinds of service types we have available. We will also want to talk about the ingress and network policies. So I think that's going to be an exciting range of different topics, which we'll reserve for primarily day number 3. But I will definitely want to spend 1 or 2 hours just specifically on services and networking. So as you can see here, we have a wide range of different topics. Does not necessarily look that much, but once we go into the details, you'll see there's a lot of nuances to certain topics, a lot to be understood. Just wanted to point you to the curriculum of the CKAD in more detail. So if you want to find out what's going to be relevant, you can find it in this GitHub repository hosted by the CNCF Foundation. I just put it here into the attendees chat. So if you're not familiar with this PDF file, you can find basically the same outline that I just mentioned directly in the form of a PDF. This will be updated over time, so it makes sense to potentially have a look at it occasionally just to see if something drastically changed in the meantime. For example, if you took a break of a couple of months while practicing for it, you may want to revisit this page to see what actually changed in the meantime. Now you can see here the version of Kubernetes that is going to be used in the test environment is going to be the version mentioned right here after the name of the PDF file. So there's this little suffix that tells us we want to use 134. That's going to be the Kubernetes version in the Kubernetes targeted environment. By the way, you can also find the same version on the entry page for signing up for the certification / buying the voucher for the certification. As of now, the price is US dollars $445. If you decide to buy a bundle, that's up to you. You can definitely do that. But here you can basically find the same breakdown, just not in the form of a PDF file. But what I find useful here is not only is the software version here defined to Kubernetes 1.34, you can see here marked in blue. And somebody was asking before, once I buy the voucher, how long can I take before I actually take the exam? It's going to be 12 months. If you do not pass the exam or at least take the certification attempts, you will basically lose eligibility to basically sign up for the certification. That's a little bit unfortunate. I don't know why they do this, but ultimately, that is just what they decided on. Now down here, last one, exam details and resources are definitely super useful. If you have more advanced questions on the exam environment or want to have additional exam tips, that is definitely something that I can suggest you read before the before signing up for the certification in more detail. All right, so that is what I wanted to mention here. For anyone that never took the certification before, this is a screenshot of the exam environment. And the exam environment is provided by the company called PSI. So PSI is the training provider, and they will provide to you a remote desktop, which will have to render on our screens. I usually just sign up with my laptop. I have to close all the other applications running on my machine. And then once that is ready, we can basically see the following test environment. On the left-hand side, you will have the different tasks that you have to go through. So you can envision tasks to be the same as individual questions or basically certain points you have to work through. And then on the right-hand side, we have the browser and the terminal window that we will have to use before we can solve any kind of problems. Now, you're allowed to use documentation and specifically documentation from the official Kubernetes documentation webpage. Anything outside of this is not allowed, but I will mention the valid URLs on one of the next slides. Don't get confused if you don't see the terminal window in the beginning. You can simply click on this little icon down here. That is the icon for bringing up this terminal window. And that is basically how you go through the certification. You can see a timer up here. This one, by the way, is for the CKA. Doesn't matter too much. The setup will basically be the same. And sometimes the number of tasks actually changes. Doesn't have to be 17 different tasks. I believe they have a range of 16 to 19 different tasks that they can ask you. I think they're just randomizing those questions. And then based on the complexity, they will basically give you a specific task here. So I just mentioned the Kubernetes documentation that you can use in the certification environment. We have the official Kubernetes documentation. I would suggest to definitely use that one. You're allowed to use the search bar here. So if you enter deployment, for example, let's say you want to find out specific configuration options, or you want to get a good starting point using a YAML file, which you can actually copy paste here directly with this little icon. You can copy paste that into the terminal window directly in the certification environment. That's super useful. And then potentially you may want to further edit this based on the instructions of the individual tasks. But that is definitely super useful. If you forgot how to do something, just don't spend too much time on this. But generally speaking here, that is what we want to be familiar with. You can see sometimes in the search results, there may be an entry for, or that points to the blog post on the Kubernetes.io webpage. Definitely also allowed. And then lastly, I mentioned before, Helm is one of the open source tools that we have to understand for the CKAD. And therefore, we can also look at the Helm documentation here. Now, I mentioned before, kube-control will be super important for passing the certification. And you will have to type kube-control quite a bit. You can type kube-control or simply use the pre-configured alias in the target environment. And the alias for kube-control is simply the letter K, which points to the kube-control executable. So if that's something that you want to set up on your local machine, you can definitely do that. You can see the command here on line number 1, and then going forward, you should be able to simply just use K and then the command/subcommand and options you want to use. Now, in earlier versions of the certification, you were not allowed to use autocomplete, or you had to at least install it yourself and spend time on it. I think that is not really a real world, and I'm glad that they changed it. They now pre-install auto-completion for kube-control. So therefore, you can start to type in the beginnings of a command or an option, and will simply provide to you with all the available options for what you typed. So therefore, use that, also install it on your local machine. This is super useful, so you can become more familiar with that kind of behavior. In the target environment, you may be faced with different kinds of Kubernetes clusters. So you don't necessarily just interact with one single Kubernetes cluster, but potentially multiple of them. If you want to learn about how the setup for those Kubernetes clusters looks like, you can definitely find more information about that down here in the, I believe, curriculum overview or the candidate handbook. There, they basically describe the operating system, how many nodes we have, and those kinds of things. So that's something that you will definitely want to check out here. All right. But if you do want to interact with different Kubernetes clusters, usually in the space of kube-control, we would have to switch a so-called context. So effectively, the context is a pointer to the target Kubernetes cluster we want to interact with, including the credentials that we need to send over at the same time to basically authenticate against that cluster. Now, you don't have to set up any credentials whatsoever. You don't have to set up Kubernetes clusters from scratch. that is more a topic for the CKA certification, but not for the CKAD certification. And therefore, all you have to remember is to basically switch the context that has been given to you for a specific task in the target environment. And the second command that you see here on screen is likely already being provided to you anyway. And it's a command that you will see in the description of those tasks. You will just have to copy paste it into the terminal window, and then you're in the right, basically, context, aka you work against the right and given Kubernetes cluster. Now, some questions will also ask you to use or operate in a specific namespace. If you don't know what a namespace is yet, we will talk about it. But generally speaking, you can think of it as a grouping of specific objects we want to manage or interact with in the Kubernetes cluster. So make sure that you use the right namespace. You can either spell out the namespace with individual kube control commands, or you can set the default that you want to use for a namespace using the first command you see here on the slide, config set context, and that will effectively basically let you use the namespace going forward with each of the following commands. Just make sure that you change it when you switch between different tasks in the target environment. Now, just wanted to give you some additional resources that you may find helpful in preparation for the certification. Here you can find a book that I wrote together with O'Reilly. You can find that on the O'Reilly platform. So if you're the kind of learner that likes to have a little bit more context around a specific topic and wants to read up on things and wants to get additional pointers, this may be a good resource to have. It's also available on Amazon, by the way. O'Reilly decided only to publish the PDF version of this book. There's no print version available, so don't be confused about that. Not quite sure why the decision was made, but I believe they decided on that, and it hasn't changed in the meantime, unfortunately. I mentioned before, there's also a video course, which is somewhat similar to what we're going to talk about in the following 3 days, including today. If that's something that you're interested in, definitely check that out. You can find the link here on my slide. And it will basically go through similar, or at least not the same exercises that you can find here in this live course. If you do want to ask me questions here in the live course, that's preferable. But if you are the kind of learner that simply just wants to skip through different videos, jump around, that is definitely something super useful. And then somebody was asking about the sandbox here again. So kube control should be available in the sandbox of the O'Reilly interactive learning environment. And if you want to learn more about the individual labs that we prepared for you for the CKAD specifically, you can find that playlist here directly on the slide. Now, I can see here I didn't update the price for the exam yet. So it used to be $395 USD. Apparently that was up to $445. But generally speaking, I will update this little screenshot that I have here. Generally speaking, don't pay the full price in general. There's usually a voucher you can find either online or in the marketing materials of the Linux Foundation, or if you want to use my voucher code here, which gives you 20% off on the total price, which would be $1.20. That would be an option that you have for reducing the price in general. So I would say never pay the full price, always look for a deal, and there are plenty of deals out there. But if you want to get started right now, you can use my voucher code, which should be available and valid at the moment. Just to summarize for the exam, what do you need to understand? I would say if you want to be successful with the exam, try to practice hands-on as much as you can. I personally decided to read the documentation from start to end. It was good to give myself some exposure to topics I had never heard of before. And then also make sure that you not only learn how to interact with kube control, but also learn additional tooling that you will need to basically interact with. For example, we will have to edit YAML quite a bit. Vim and VI are pre-installed, but you can install other editors if you want to. For example, Nano, Emacs, depending on what you want to use, but you will have to spend your own time on it. And then be comfortable with bash and bash commands, simply because you will have to run many of those commands in the terminal window. And then when it comes down to the actual exam, I'm a morning person, so that's why I schedule usually my certifications in the mornings. So let's say 7 a.m. That may sound outrageous to you, but that is what I do. If you're an evening or night person, definitely go for it. PSI usually provides plenty of slots for you to be able to pick the time that you're most comfortable with. And that is super useful. And if you haven't seen it yet on the sign up page, you actually do have one free retake for the voucher that you purchase. So if you fail the first attempt, not a big deal. Don't stress out about it, but take it as a way to basically understand where your gaps are, your knowledge gaps, and basically brush up on your knowledge even more based on that. So therefore, on the second attempt, you can definitely ace the exam. All right, so that's all I got on the exam environment, curriculum, objectives, learning resources, exam tips. If you have any additional questions, do let me know now. If not, we'll probably take a 5-minute break now before we jump into the first bigger domain in the certification, which is going to be on the application design and build. So therefore, hang on a little bit. Now would be a good time to get a coffee or take a restroom break. We'll get right back after my timer runs out. I will usually put up my timer here. And I'll set this to 5 minutes, and then we'll resume right after. But feel free to ask any questions in the meantime. Happy to help out. And then we'll jump right into the first topic. All right, so let's get back to things. Jump right into application design and build. And the topics we want to talk about is first, the application developer perspective on building your application. And that basically includes building a container image from scratch and then basically at least trying to run it in a local container runtime. Excuse me. We will be using, or I will be using Docker Engine here, but you can use pretty much anything else that lets you build a container image. You can use, for example, Podman or something else, kind of up to you. And you will, in fact, get different options in the exam environment. I would say Docker Engine or BuildKit as the building tool of Docker Engine for container images is likely the most safe option here, or the most common option. But I believe they'll let you use Podman, and that is pre-installed as well. Then we'll talk about single and multi-container pods. So here we'll talk about the concept of a pod in general. How can it be configured? How do you run applications in Kubernetes, either with a single container, and then later on, we'll talk about the use cases for wanting to run multiple containers. We'll also talk about slightly different use cases for running workload. So it doesn't have to be an application that keeps on running once you started it, but you could also decide to wanting to fulfill other use cases. For example, you may want to run a one-time workload and execute that. For example, you may want to maybe massage some data, which maybe should only happen once, or you will want to export or import some data specifically. And for that purpose, we could be using a different Kubernetes primitive called the job primitive, Or alternatively, there's also the use case for wanting to run scheduled workload, and that is usually a good option for doing something periodically. You can envision the cron job primitive to be similar to the Unix cron job, except that it basically runs workload in Kubernetes itself, or at least it controls it. Let's put it that way. And then lastly, I will also want to talk about different storage options for your containers. Generally speaking, you may have noticed if you dealt with containers before, there is a root file system available from within the Kubernetes container, or any container really available, whether you run it, say, in Docker Engine, or whether you drive it off of Kubernetes. But that's usually not the best option for storing data. One reason could be security, for example. You may want to externalize that data, or you will want to persist it for longer, which is not supported by the what I almost call a temporary file system for a container. And therefore, Kubernetes gives us options for letting us write and read data into so-called volumes. And we will talk about the different use cases here: ephemeral volumes for data that we don't necessarily want to persist for longer, that we can easily reproduce again, versus persistent data, which is covered by so-called persistent volumes. So we'll talk about all of those options here today. So let's get started. Take a step back and talk about image and container management first from the application developer's perspective. Before we do so, let's briefly talk about the different terms that are available in that space. So for anyone that is super new to containers and cloud native environments, just wanted to demystify a couple of things here. So when we talk about a container, we're usually talking about a packaged application that is available to us, which includes the usually the operating system, the runtime environment, the binary of your application, potentially any configuration needed by your application, and external dependencies that you may need to run your application, all bundled into one single unit of software, which we can execute using a so-called container runtime engine. So the container runtime engine is a software component that lets you run one or many containers on a operating system. And just to give you some examples here, Docker Engine, Containerd are some implementations of the specification of such a container runtime engine. When you run applications inside of a container in Kubernetes, Kubernetes will effectively delegate their responsibility of running the container to the installed container runtime engine that usually runs on the worker nodes of your Kubernetes cluster. And then lastly, when we talk about the container orchestrator, you may be asking yourself, well, we already have the container runtime engine. Why do we need something else on top? The reason is we will likely not want to run just a single container or 10. We'd likely want to run hundreds or even potentially thousands of different containers in a cluster. And with certain aspects taken under consideration, for example, scalability, networking, all kinds of other aspects that may be of importance. And therefore, we need to have a higher level concept here, and that is effectively Kubernetes. There are also other kinds of container orchestrators, depending on what you want to use. But given that we are talking about Kubernetes here in this course, we will primarily focus on the container orchestrator called Kubernetes. Now, when we want to build, or let me step back one step here. When we want to run a container in a container runtime engine, we will first have to build or use an existing container image. So the container image is basically the specification on how your application should be bundled into that single unit of software. And that includes where, for example, your application binary comes from, what ports to expose, what operating system to use, what security features to set, and those kinds of things. So to be able to build that container image, for the most part, we will have to use the so-called container file, which basically defines those instructions one by one, so we can use that to effectively build the container image. Now, there are also builders or building tools that don't require the definition of a container file, out of scope for this course and also out of scope for the CKAD certification, but just wanted to mention it on the sideline. So the container file is not really mandatory in that sense. There are other tools that take different kinds of approaches. And then lastly, once it comes down to wanting to use the container image, we may want to not only have it locally on the machine that actually built it, but we may want to distribute it to other team members or even the internet out there. Maybe you want to build a container image that's super useful for anyone else. And therefore, you will want to place it on a so-called container registry. So the container registry is basically a registry of different container images organized in a meaningful fashion, which lets you basically publish a container image to and lets you consume from it. So you can think of it as a binary repository, similar to what we know from, say, jar files in Java or NPM modules in Node, or other ecosystems that you may know of. And the same concept applies here. The container image registry is simply a registry that lets you store container images so that they can be consumed by other team members or anyone that really has access to them. Typical examples here, Docker Hub, which is the public registry for Docker containers or Docker container images, but there are plenty of other ones out there. GCR from Google, there's one from AWS, and many other ones. For the most part, I would say go with a private container registry. Don't necessarily go with the public ones for security reasons, again, simply because in general, everyone is able to basically publish their own container images to Docker Hub, for example. And therefore, that could also include publishing code that is malicious once you run it within the container runtime engine. So therefore, be a little bit cautious on what you run on your local machine, and therefore pick usually a container registry or set it up within your company that allows you to only have access to those curated container images within your organization. So here's a question, comment. Here's a what's the difference? Basically, what's the difference between the container image and the container? So basically, the container image is the binary that you can make available on the container registry that you can download on the machine that wants to create a container from it. So you can think of the container image as the blueprint for what needs to happen at runtime, but it doesn't really execute anything. And the container you can think of as an instance, so basically an instantiation of that container image. And of that container image, you can create basically multiple instances with different runtime parameters. So similar to, say, in Java, we have a class definition and the object we can create from it, or generally speaking, in object-oriented programming languages. And therefore, that is the main difference. So class is basically similar to the container image. So how should this look like at runtime? And then the actual instance of that container image is the container. So hopefully that's a little bit more clear. Side note, if you want to learn more about containers in general, this is not the right course to be joining in general, because we could probably have an 8-hour course just on containers and the container runtime engine. So therefore, if you're somewhat new to this topic, check it out in a different course. We'll not go too deep. Here we'll just talk about what's going to be relevant for the CKAD certification. So here's one example of such a container file. You can see that we have different instructions, for example, from, work dir, copy, entry point, expose. Those are not the only instructions that we have in such a container file. And therefore, we will have to learn about that in more detail. In the CKAD certification, you will actually see here that we will only need to have a high-level understanding of those instructions. And you can see here we have from, workday, copy, entry point, expose. You will likely not even have to write your own container file. It's likely given to you. I think it's a little bit out of scope if they were to ask you about this. But generally speaking, if you are an application developer, it's knowledge that you need to have anyway. And therefore, become more familiar with that concept, with those instructions, and many other things. But what you can see here is a fairly simple example of a Java-based application that you will want to run later on in a container. And with the definition that you see here on screen, you can build a container image using specific commands of those building tools. Oops, give me 1 second here. Just wanted to show you some of the commands that are going to be relevant for the exam. Here I'm using Docker, the Docker executable that I installed on my local machine. And I will be using the build command to effectively point it to a so-called context directory. And the context directory is the directory that the container file lives in. Usually, if you're using Docker, you will likely use the file Docker file. Just keep in mind, Docker file and container file mean the same thing. But if you're using the building tool for Docker, it will usually look for the Docker file by default. That's the default file name. Within this context directory, you will not only have the container file or Docker file, but you may also have additional files you want to copy into that container image when you run the build command. Now, every container image needs to have a so-called tag. And unfortunately, the terminology here is a little bit conflated. When they talk about a tag, they usually talk about the container image name separated by the tag, so the version that we want to assign to that container image. So unfortunately, they just kept on saying tag, but ultimately it's a combination of a version and a container image name separated by that colon character. Generally speaking, it's a good idea to go with semantic versioning here, so major, minor, patch version for the tag assignment. And therefore, you can basically indicate to end users what actually changed with your container image. Once we kick off this command, it will basically look at your container file and those instructions, and will basically produce that container image that I mentioned before. Every container image that you built before will have a so-called container image ID, so you can easily reference that as an alternative to the Docker image, as an alternative to the container image name and the tag assigned to it. So you can either use this little short hash, or you can use the full name of the container image plus the assigned version. So once we build it, which oftentimes doesn't take too long, you should be able to list the existing images on your local machine. That is oftentimes referred to as the local registry of your images, which need to be available before you can actually use them. And you can see here, once we build the container image, we get an overview on the name, the tag, the ID that I just mentioned, and the size of it. To be able to now run the application, we have to basically instantiate that container. So the container is basically the instance that actually runs the application inside of a container. Without that container, you wouldn't have a running application whatsoever. The container image is basically just a binary representation of the container you're about to create. And to be able to do that, you will have to use the run command. And the run command is the command that lets you either point to the hash that I mentioned before, so the container image ID, or the full name and the version of that container image. And if you want to expose your application to any consumers, you may want to expose a port as well. You can see here that is the port mapping. So -P is the command line flag that maps your host port 8080 to the internal container port. That is effectively the port number that exposes your application or that has your running application available. So you may know for Node.js-based applications, they oftentimes, at least by default, run on port 3000. Java-based applications oftentimes run on port 8080. So it kind of depends on what port you're running your application. Now, for any running application, you can inspect the logs being produced by your application. And that includes standard output and standard error, which we can inspect using the logs command. We can also interact with the running container using the exec command. So the exec command lets us open a interactive shell, which you can see right here, which lets us navigate the root file system of that container I mentioned before. We can inspect all the processes running inside of that container and so on. If you want to simply just run one single command, you can do that also, but it would not be a interactive execution of that exec command, which is defined by the -it command line flag here. You can simply just run single commands and then not open an interactive shell if that's something that you prefer. When we want to place a container image to a registry, you will likely want to stick with the conventions dictated by that container registry. And those conventions are different between different implementations. For example, it will be different between Docker Hub and Artifactory and say the ones from cloud providers. So you will have to look it up in the documentation, but generally speaking here, we have one example here for Docker Hub. Docker Hub basically requires you to prepend your container image name using your account name. So once we created the account, and my account name is bmushko, to separate that by the slash so it knows where exactly to place that container image into the registry. And therefore, that is one of the reasons why I may want to create a new tag for my existing container image, because I may want to deploy it to different kind of registries which have different naming conventions. And the tag command lets you basically create additional tags for existing container images. Just be aware, it does not create a copy of that container image. It will simply use the same container image. It doesn't use up additional space on disk. It simply just creates another identifier, so to say, where you can see image ID is actually pointing to the same container ID here. And then lastly, once you want to make available that container image on a registry, you would first have to authenticate usually against that registry. Within Docker, you have the login command that lets you log in and provide your credentials against that registry. And then lastly, you would use the push command to push your container image with the right tag to that registry. Now, there are a couple of other commands that I want to mention here that are potentially relevant to the exam, which is the save command and the, I think, load command. So therefore, sometimes you may want to deal with files instead of just a binary or proprietary file representation of your container image. You will want to basically place it into a tar file. That is the way to do it here with the save command. So if you want to produce a file representation of your container image, you can definitely do so. This would be a good option if you want to, say, copy the file onto a shared disk or something, or want to create a backup instead of using something that doesn't have to be published to a container registry. And then lastly, once you want to import it again, we can do that with the load command, and the load command lets you then point it to an existing tar file, and it will then make it available for that local registry that can be used with the Docker command. So for example, if you want to exchange different container images, but you don't want to publish it to a registry yet, then that is one option you can choose from. All right, so what I usually do here is to give you some time to play around with exercises. Oftentimes, I actually do have some attendees that want to do this at home. They just want to hear the lecture, me talking about the different theoretical topics. So what I want to do here is I want to make this a democratic process, so nobody's going to be disappointed here. So if you give me the thumbs up on this pulse check, that means you will want to spend about 10 minutes per exercise on your local machine to play around with things. If you give me the thumbs down, that basically means, hey, just skip it. I just want to see the demo. Just talk about it. And based on that result, I will effectively make a decision based on how we roll within this course. So I'll just give you maybe half a minute or so to select from one of those options. So again, thumbs up is yes, I want to spend some time and playing around with things, versus I just want to see the demo basically. For anyone that wants to see the demo, oftentimes it's likely better to just go with the video course, which is available on the O'Reilly platform, versus the live course, which is usually better to play around with things and then ask questions based on the issues that you run into. All right, I'll give it 10 more seconds and then we'll resolve. Yeah, I think you will see the result on screen as well, if I'm not mistaken. All right, we'll resolve it. So it was 22% versus 9% on the thumbs down. So we will go through the individual exercises here. I will definitely give you some time so you can play around with things. And I think that will basically build a better foundation for you in general to be more comfortable for the exam in general. All right, so I will turn on my timer. And for this one, I'll give you about 10 minutes. So what you need to have for exercise number 1, if you go right here, is that you have a container building tool installed. For example, BuildKit, Podman, or something else. I'll make this a little bit bigger here. So you can install it directly from there if you don't have it available yet. You can also choose from the interactive lab, which is available on the O'Reilly platform. And what I prepared for you is an existing Docker file. So if you click on this link here, it will already bring you to this Docker file, so you don't have to necessarily understand it. I will talk about that a little bit, but in general, it's out of scope to basically understand Docker in more detail. And I just want to spend really one exercise on using a building tool to produce that container image, so you had some exposure to it. All right, so I will turn on my timer here 10 minutes. And in the meantime, I will look at the outstanding questions that may have come up, and we'll answer them asynchronously. All right, so let's have a look at the solution here. I will bring up my terminal window and we'll go to number 1 so you can later on know where we are. Let me make this even bigger here. Okay. And what I want to do here in the first place is to navigate to the app directory. And in here, this is effectively our context directory that I mentioned before. So if you look at the Docker file in this case, you will see we are building a Node.js-based application. This is the base image that we're using here. And there are a couple of instructions that copy files into the container image when we produce it. We also run a executable here for npm. So this is all specific to node-based applications and how to build them. This will look very different if you were to build a Python application versus Go or say Java. But that is more on the side of building or at least defining the container file. But ultimately, we're running a Node.js-based application. And if you want to see what we're running here, that is the index.js file that you can also find in the same directory here. In this application, we are bringing up a HTTP server, which runs, I believe, on the default port here, which is port 3000. And when we make a call to it, we will get a response that says hello world to us from the root URL context path. And then here in this statement, we are simply just rendering something to standard output. That is one initial message that is being rendered when we bring up this HTTP server. All right, so let's get started by effectively running the Docker build command. I believe I already have the corresponding command here in my history, in my shell history. You can see a couple of things are happening here. For example, if you didn't have the base image, it would effectively download that one. But you can see after a while, it works through all of those instructions and builds the corresponding container image. So let's see if we can find that container image that I just built. There are likely going to be other container images available here. Pretty old stuff. Let me see if I can find my hello world or whatever I called it here, Node.js hello world. And that is the one that I just built. I believe usually it says when it has been built. And I don't see this information here anymore. Maybe they removed that in the meantime. But as you can see here, we have the container image ID, the size, which is relatively small for that kind of application. And now we can use that to actually run the application. So you cannot run a container without the container image. So that came up as a question earlier. So therefore, make sure that you build it in the first place. And to actually run it, we are going to either use the ID here that you see or the full container image name plus the version. So we're going to use the ID in this case. So I can say use this port mapping here. So basically that means I want to map my host port 80. So on my local machine port 80 to the running application, which is being exposed on port 3000 within the container. And this will basically make it accessible on my host machine on port 80 so it can make calls to it. So you can see here that I ran this in what they call detach mode, which means free up the shell terminal prompt again. Simply just run that in the background. And that's exactly what we're doing here. You can also look at the currently running containers, which I didn't have on the slides, with the command docker container ls. And the one that's currently running here is my Node.js hello world application. And you can see the port mapping at the end. Now that we have the application running, we can also say make a call to localhost. So that's the running application inside of the container on my local machine. You can see that I get back the hello world response that I mentioned before. And of course, this should also be available if we simply spell out the port. In case the port were to be different, we can have a look at the logs of that container. And for basically retrieving the logs, we can have a look at the ID of that container, of that running container. So apparently that's not available. That's interesting. Oh, maybe I spelled out the wrong one. I added a 0 here in the end. And you can see here the initial message that was rendered by the application when I brought it up is available here. Magic happens on port 3000. And then one more thing I want to show you here is the creation of the tar file. Just real quick, what actually happens when you run the save command. The save command will effectively just create the tar file that I mentioned here that I spelled out with this command line flag. Now you can take this tar file if you wanted to and copy it on a shared drive or do something else, create a backup from it. That's up to you, but generally speaking, we usually want to publish the container image to a container registry, which lives outside of your local machine, of course. And one of those container registries is called Docker Hub. If you're not familiar with that one, you need to have an account to be able to basically publish images to it. You can see sign in here. Already have my sign in place. And what you will be able to find is that I already published a whole bunch of different container images here. For example, Java app, Spring Boot app, and a whole bunch of other things. And I could do the same thing, by the way, with my container image that I just created. I'm just not going to do it, but you can definitely do it if you want to. But just be aware, you need to authenticate against it first. You need to have an account and then use the right notation. It goes beyond what you need to understand for the certification in general. All right, so let me see if there were any questions. Are there any more questions on the process of building a container? If not, then we'll basically transition over to Kubernetes, where we can use a container runtime engine that basically runs an existing container image that may exist on a container registry. All right, it doesn't look like it. So what do you need to understand for the exam? I usually have those little summary slides here, which are called the exam essentials. So you will need to be familiar with the general terminology here. You will have to interact primarily with the builder tool that we've been using here. So underneath, what they call that component is build kit in Docker Engine. And then we basically pointed build kit to a existing Docker file. I think it would be helpful if you have a better understanding of those instructions, because later on you will likely want to build your own container files. Probably not necessary for the certification, but long term, if you want to use containers more heavily, there's almost no way around it. And then when it comes down to the actual process, we ran a bunch of commands. We learned how to interact with the running container then once we had the container image in place. And that is basically the extent of commands you need to understand for the certification. So nothing super crazy, but just be aware that you need to be familiar with some of those commands available. All right, so let's transition over to the usage of kubectl, which effectively is your client when you want to interact with anything within the Kubernetes cluster. So with the help of kubectl, which is a separate executable that you have to install on the machine that you want to run the commands from, you can basically create new pods, you can edit existing deployments, you can delete existing objects, and basically create the objects that you need for running your own application. And for that purpose, you will have to understand how to use kubectl in more detail. And that is what we're going to use here or talk about in this section of the course materials. Now, before we jump over to using kubectl, wanted to make the same analogy that I made before when we talked about the container file and the container image. So you can think of the container file as the blueprint, the specification for how that container should look like at runtime. And then the actual instantiation of that container image, which is the container. And ultimately, we have a similar analogy here in Kubernetes, where we will usually talk about a Kubernetes primitive, which is the specification of a specific piece of functionality in Kubernetes. So for example, there is a primitive called a pod, which lets us run applications inside of one or many containers. And the pod itself is basically the specification of how this should work at runtime. And then the actual object is the instantiation of that pod, which has a unique identifier and usually also a unique name assigned to it. So the same concept applies here. When we want to basically create a new pod, we would effectively use the kubectl command line tool to create an object of that primitive. So the same concept applies here. Hopefully that became more clear. Many of those Kubernetes objects follow a specific specification, which is available in the specification of that primitive. So for example, for a pod, there is a definition of how we want this object to look like once we actually create it in Kubernetes. Now, there are different kinds of, I would say, specification sections that we need to stick to for most of the Kubernetes primitives that we want to create objects for. And that is usually the API version, the kind, a metadata section, a specification section, and then the actual representation within Kubernetes, which is called the status. So we will see this over and over again when we write YAML manifests, which we will want to use, similar to container files, to create objects from it. Now, let me talk about the individual portions here in more detail. And the portions that I mentioned here is the API version, for example. So API version is basically the version of the specification of one specific primitive that we want to represent with the help of a YAML manifest. Oftentimes you will see that the API version is just a major version, for example, V1 or V2 or something like that. But some of the other primitives, specifically more advanced ones, or CRDs, which we'll talk about later what they are, they oftentimes have a specific group assigned to them. So it's basically just a grouping, which is a prefix before them. So for example, the deployment primitive uses the group apps. So therefore, the API version for the deployment is apps/version1. Then we have the kind. That is effectively the kind of primitive we want to represent. That could be a pod, a deployment service. We'll talk about all those kinds of primitives available in Kubernetes as we go through the course. Then we have a metadata section, which is effectively a high-level information or meta information of that object. In here, you would find the name of the object we want to create. We can assign labels and annotations, and we'll talk about that in more detail. But also the namespace would be part of it. So the grouping within Kubernetes, how we want to organize those objects. And lastly, we have the specification section, which basically lets you describe how this object should look like at runtime. So Kubernetes will basically use that information to understand how that object should be configured. And then lastly, given that the desired state, so the specification doesn't always reflect reality, which could be deviating, there's also the status, which is the actual representation of that object at any given point of time. Sometimes you cannot transition into the state that you wanted to define here, and therefore actual state may be different from the specification. But ultimately, status is something that you don't have to modify on your end or even specify. It's something that Kubernetes will assign automatically based on the internal representation. Now, when we want to interact with Kubernetes, I mentioned before, we have to install the kubectl executable. You can definitely find those installation instructions here in the documentation. And so if you were to search for kubectl, you should be able to probably find here install tools. And you can see that the installation instructions are different based on the different kinds of operating systems. So for example, on Mac OS here, you can install it using Homebrew, so package managers, or simply using a curl command. So it kind of depends on your operating system, how this should be done. But all of those instructions should be available. Now, kubectl and the size of the executable is relatively small. And once you have it in place, you can periodically upgrade that just to make sure that you have the latest version. But it's not even necessary to do this all the time because kubectl itself, the executable, doesn't actually change that much. And keep in mind, there's a different release cycle usually between kubectl and core Kubernetes. It's definitely possible to use an older version of kubectl to effectively interact with a newer version of a Kubernetes cluster, but it's usually a good idea to keep them in sync somewhat with their latest versions. Now, when we run kubectl, we usually want to run a specific command. There are also subcommands that I don't show here specifically, but there could be a get pod command. So when we say here kubectl get pod app -o YAML, that effectively means give me a YAML representation of a pod with the name app, and it will basically then render that representation on the console output. Now the flags are optional, also the name is optional. You can also list all the objects of a specific type, and therefore that is how you would basically operate using kubectl. Now we'll use kubectl pretty heavily, and I want to show you the different approaches that you can use in the test environment. We usually differentiate between the imperative object management approach and the declarative object management approach. I would say the imperative object management approach is a good option just for the test environment to be quick and efficient to solve problems, but it's likely not something that you would use in a Kubernetes production environment. I will talk about the declarative approach in a little bit, but as you can see here, there are in fact no YAML manifests involved. I will simply just imperatively spell out what I want to create, how I want to create objects directly with options from the command line. Now, with the first command, I simply create a new object. With the second command, I create a new pod in that namespace. I can also edit existing objects using the edit command. So all of those commands don't actually involve creating a YAML manifest in the first place. We'll simply just say ad hoc based on the command line options and flags that are provided here, what we need to manage. This is different if we talk about declarative object management. And declarative object management will always work based on the definition of a YAML file, which has the different sections that I mentioned before. Now, usually you want to go for declarative object management in production environments simply because you would want to check the YAML files into version control. So you can basically track when something changed, why it was changed, who changed it. Then based on that, you can make additional changes in the Kubernetes environment. But generally speaking, the imperative approach does not keep a track record. It simply just makes those changes, and then it's basically finalized. But as you can see here, we can run the same kind of operations, for example, creating objects, making changes to objects, deleting objects, and those kinds of things by simply just pointing it to a specific YAML file. Now, you can also use a approach that I would usually coin as the hybrid approach. This one basically combines the imperative command with a way to basically redirect the output of that command into a YAML file. This may be a good option if you want to further modify the contents of that file. So maybe you just want to produce a good starting point, and then later on you want to further modify it. So that would be one option to do it. So here's a question: can you use the imperative command to create a YAML file? That is exactly what you see on screen right here. Is this the best practice? It's one practice. There's not a best practice, I would say. Just keep in mind that when you redirect the contents of that command here into a YAML file, it will basically populate a couple of portions in that YAML file that you usually don't need. So I would usually strip that out, but generally speaking, you will land at a similar solution as when you were to go here, say go pod, search for it, scroll down, and then copy a portion of this here. So this could be a starting point when you talk about best practices. That is a way to do it. But generally speaking, yes. So here's a question. Does the command also run or just print the command? So you can see here there's a flag that I didn't mention here before, dry run equals client. So effectively that means run this command in a dry run mode on your local host machine. And effectively that means don't send the command to the Kubernetes cluster. Simply just do it on your local machine. And therefore, it will not basically emit that command. It will not create the object. It will simply only create the representation of that object in the form of YAML and then redirect it to the YAML file. It does not print it to the console, by the way. You can print it to the console if you leave out this redirection portion here. But it kind of depends on what you want to achieve. So I would say, as a little summary here, for the exam itself, you will likely want to go with the declarative approach because it already brings you into the mode of thinking for production Kubernetes environments. I totally understand that 2 hours in the exam is not a lot of time, and therefore we will want to save as much time as possible. So therefore, it's definitely possible to also use the imperative command. So therefore, you usually don't have to find a good starting point in the documentation, copy it from here. So if you prefer to use the run command, that's completely fine. But I would say in production environments, you will always want to go with the declarative approach. And just be aware that the imperative approach not always provides all the configuration options that you have with the YAML file. So it's somewhat limited. So just be aware of that. And then lastly, one more thing to mention here, once we create objects, you will potentially delete them at some point of time as well. In the exam environment, if you delete a pod, it will try to gracefully shut down the process running inside of the container, which can take up to 30 seconds. That's the default grace period, what they call it. And therefore, that is not really time we want to spend necessarily. And therefore, you may want to remember the --now flag, which is basically indicating to the container simply sig kill the running process and don't wait for it. It's not something we would use in production, but it's super useful in the test environment. All right, any more questions on using kube control on a high level? Obviously, we haven't talked about all of the commands, but that will come as we go through the course materials. And if there are no questions, we'll take a 5-minute break and then we'll jump right into using Kubernetes in more detail. And here we will want to learn about pods and namespaces. How do we actually run workload in Kubernetes? And how do we organize those pod objects within Kubernetes? So I think that's going to be exciting. So within the next, I would say, half hour, you will have something running in Kubernetes. All right, I see no question at the moment. So I'll turn my timer on to 5 minutes again, and then we'll reconvene pretty soon. All right, so let's have a deeper look at pods and namespaces. So I would say of all the Kubernetes primitives you want to look into, likely the pod is the most simplistic one and the most essential one, simply because it lets you run applications inside of Kubernetes. So when we talk about a pod, what exactly is that? It lets you run one or many containers inside of a single pod. And not only does it do that, but it also allows us to mix in functionality like security, resource definitions, storage, and many other concerns that we'll talk about in the course of this training. Now, every object that we create in Kubernetes will live in a namespace. So it's not really specific to a pod, but I wanted to mention this concept early on. Ultimately, every Kubernetes object will live in a namespace. And by default, there is a namespace already in place. So if you don't spell out what namespace it should live in, it will live in the so-called default namespace. So the default namespace is a existing namespace that cannot be deleted. But in most cases, you will not want to place your objects into the default namespace because you want to have more efficient grouping based on maybe a part of the organization or an application stack, so multiple objects that belong together, or maybe all the objects of a specific team live in one namespace. So it's really not a strong suggestion or recommendation on how to organize those objects, but ultimately based on, I would say, functionality that belongs together. So let's have a look at how that plays out. So we just talked about the pod. It lets you run a process or application inside one or many containers. I would say for the most part, and that is oftentimes a question that beginners have, when I want to create multiple microservices that may want to interact with one another, do I place them into a single pod, into a single container, or would I create multiple containers in the same pod, or would I create multiple pods with individual containers? And I would say the best practice here is every microservice lives in one container that belongs to one single pod. And we'll learn about some other use cases for wanting to run multiple containers inside of a single pod, but usually it's not the case that multiple microservices would be run within the same pod in different containers. And there are good reasons for it. For example, scalability, security, and multiple other things. So you will want to basically separate those. So usually how you would get started is to create one pod that runs one microservice in one container. And then we can basically add additional functionality for that specific application going forward. You will actually see that I will show you the imperative command and will then compare it to the declarative approach as well. So you always have both approaches in one place if you want to go back. And I usually start by showing you the imperative command for creating objects. And the command that you see here on screen is the run command, which lets you create a new pod object from a container image. And you can see there are multiple different command line flags that we can or cannot spell out. So for example, as a mandatory command line option, we would have to spell out, I believe the only one is the container image. That is a mandatory one. All the other ones are optional, or at least it will fall back to sensible defaults. But ultimately what we're running here is Hazelcast. That is a something out of the Java world. I believe it's something around Java messaging, if I'm not mistaken. I would have to look it up exactly what it does. I've personally never used it, but I used it as one example. And you can see there are different options that we can provide upon the creation of the pod. So for example, we can define the port. We can define environment variables. We can define labels we want to assign to that object. And here's also one more option called the restart option that will basically determine if there were to be an error when we start up the container with the process running inside of it, what should happen in that case if it fails? Should the container be restarted multiple times before we give up, which is the default behavior, or will we just fail in the first place? And the fail in the first place option is basically to define restart equals never. So if the process fails on the first attempt, it will simply just mark this pod as a failure. Now here's the representation of such a pod in the form of a YAML manifest. So you can see the different sections that I mentioned here before: API version, kind, metadata, and the specification. And you can see here that some of the options that I mentioned earlier are mentioned here as well. For example, the container image, the name of the container we want to assign, the container port, the restart policy, and the name of the object. So ultimately, what we would produce with the imperative command is something similar to what you see here on screen. Now, once we create a pod inside of Kubernetes, it will usually be placed onto a so-called worker node. The worker node is one of the nodes in the Kubernetes cluster that is responsible for running workload. And as we place the pod onto worker node, the container image that I just spelled out in the imperative and the declarative approach needs to come from somewhere. Now, you may remember I mentioned earlier that we need to configure a container runtime engine, and that is the software component that's actually responsible for downloading the container image from a registry and storing it in the local node container image registry that the pod runs on. If you already have that container image available in the local node container image registry, in that case, it will simply be able to reuse it. But if you were to change the tag or the name, in those cases, likely the container runtime engine will have to check again if it already has it. And if it doesn't have it yet, it will simply download it and makes it available. Once the pod has been created, it doesn't necessarily say much about the runtime functionality or the runtime status of that object. But we can thankfully inspect that one. So you can run the kubecontrol get pods command to effectively give you the list of pods in the default namespace. Now you can see here, I'm not spelling out any specific namespace, and that basically means we're checking objects in the default namespace. Now you can see here that we created one pod object with the name Hazelcast, and there are other columns assigned to it. For example, ready, status, restarts, and age. I think age should be self-explanatory. That's how long the object existed for. Then we have the ready column, which basically tells us on how many containers we're running inside of that pod and how many of those are currently functional. So 1 out of 1 means here that we have 1 ready container out of 1 in total. We have a status which is currently running, so that's a good sign. So running basically means we have a running application. There could be error statuses available here, which we'll come to pretty soon, but ultimately you want to look for the running status, which is the first indication that the application should be functional inside of the container. Then if the container needed to be restarted multiple times, the number of restarts may be a different number than 0. So if something went wrong, it tried to restart, then you will see a different number here. Now, with the command here, we don't necessarily just have to render the full list of pods. We can also decide to render the details of one specific pod, as you can see here by spelling out the name of the pod. Now, overall, the pod usually transitions through different lifecycle phases. And the lifecycle phase that we are usually looking for is running. Now, under certain conditions, running will transition into succeeded or failed. So succeeded could happen if the process that you're running inside of the container simply finishes. So for example, you run an echo command, and the echo command will simply just print a message to standard output. At some point of time, it will simply just transition into succeeded. So the pod object will still exist, but the underlying status of that object will transition to succeeded. Now, obviously, things can go wrong, and in those cases, you will probably see a specific status message, and that will be indicated by the lifecycle phase failed here. So that's more of a higher level bucket when you think about those lifecycle phases. Now, you can also see pending and unknown here. So unknown basically means it likely has not been assigned yet or has not been created yet fully. And pending means we're still waiting for a worker node to become available, or even control plane node that can run that specific pod. So it usually indicates a potential issue, but it can resolve itself over time. Kind of depends. So we created a pod, and when we look at the details of that pod object, we can identify some of the information we've already seen when we run the get command. But if you want to get more information, including information that was populated at runtime by Kubernetes, for example, the IP address that is assigned to a pod automatically, then you can inspect that using the describe command. So we can say describe this pod with a specific name. And you can see it gives us a textual description of the object, not necessarily YAML representation, which you can get as well if you want to. But the describe command is basically just a human readable form of the YAML representation. Now, the IP address here is assigned automatically by the CNI that has been installed in the Kubernetes cluster. So the CNI is responsible for allowing pod-to-pod communication, for example. And that component is responsible for also assigning a unique virtual IP address. Virtual because it's not going to be available from outside of your Kubernetes cluster. And therefore, it's one way to basically make a call to that pod. Later on, we'll actually talk about why this IP address is not a good way to make a call to a pod. It's mostly being used for troubleshooting purposes. But ultimately, when you restart a pod, for example, if you delete it, recreate it from a YAML manifest, for example, it is definitely possible that this pod will lease a different IP address, and therefore it's likely not a good option if you want to configure an endpoint for microservices that want to communicate with one another. That is something we'll talk about in the networking section on day number 3, but for now, we'll use that virtual IP address, understanding that it's not going to be stable over time necessarily, but we can use it to basically talk to it. Now, similar to the Docker command, we also have a logs command here. So you can see here we can ask for the logs of a specific container. So if the application produces logs, you can see that it will print it out to the console. There are different command line options that I will likely not mention here, but one of them could be the follow option. And the follow option is a good option if you want to follow the logs, basically tail them in real time. So if you want to troubleshoot what's going on within a container, that's likely a good option for you. And similar to what we've seen in Docker Engine, we also have the exec command, also with the same command line options. So we can open a interactive shell to that container if you want to navigate it more deeply, or if you want to troubleshoot it, versus just running one single command, which will render to us the output of that command, basically. So depending on what you want to achieve here, you will go for one of those options, either interactive or non-interactive. Now, I wanted to mention a couple of things in regards to troubleshooting a pod that has issues that maybe exposes some error. And for that purpose, it's usually oftentimes useful to make a call to that pod and basically inspect it in more detail. So one of the commands we could make here is to make a network call to the underlying application that you're running inside of that pod. And one way to do it is to use curl or wget or a different kind of command line tool that can make a network call. Now, the IP address that I mentioned before is virtual and is only available from within the Kubernetes cluster. So that means from other pods that run within that Kubernetes cluster. And therefore, we may want to go with the option of running a temporary pod that lets us basically identify if the application is up and running from within the Kubernetes cluster itself. And for that purpose, I oftentimes use a so-called temporary pod, which can be created using the --rm command line option. That is the option that lets us basically run a single command. Then afterwards, we will delete the pod automatically. This is a good option if you don't want the pod to be hanging around just for troubleshooting purposes. But you can, of course, also create a pod which will stick around for longer. Now, I mentioned before, we can configure containers in more detail and pods. And one of those options that we use quite a bit as application developers are the usage of environment variables. So environment variables are oftentimes used to basically be evaluated at runtime by your application to basically configure it in a specific kind of way. So for example, if you're familiar with the Java Spring Boot framework, you may know that they have the concept of a profile, and the profile will basically just point to different configuration values and options that you want to expose potentially. That is something that you were to be able to set with key value pairs of environment variables. We can also inject additional configuration options like connection URLs, usernames, those kinds of things. Those are all optional, but here's one example how to basically set it. Now, when we talked about the container image before, we usually set a entry point command for that container image, which means that would be the command that would be executed every time you create the container automatically. Now, under certain conditions, certain container images don't provide that entry point, so they don't necessarily run a command. Therefore, the container image, the container would fail in the first place. I would say not fail, it would basically start, but then finish afterwards, because there's basically no long-running command that we want to execute from within the container. Now, on the Kubernetes level, we can also provide a command and arguments optionally if that's something that you want to configure. Ultimately, if you do provide the command and the arguments, it will effectively override what the container image comes with in terms of the entry point. And that is a way to basically run a different command or modify an existing command or provide more options if that's something that you want to. I mentioned before, not only can we create new objects, but we can delete them as well. So if we don't need an object anymore, you can simply run the delete command. And the delete command works in the imperative approach as well as the declarative approach. So both options are possible. And that is effectively how you delete specific objects here, depending on what kind of object you're talking about. But the delete command itself will apply not only to pods, but pretty much anything else, like deployments, services, horizontal pod autoscalers, what have you. Now, I mentioned before the default namespace, and I wanted to expand on that a little bit. The default namespace will exist in any Kubernetes cluster. So if I go in here, for example, say get namespaces, you will actually see that I will get the default namespace. The default namespace is the one that exists by default. And any command that you run will always fall back to that default namespace if you don't spell out an explicit namespace for that command. So if I were to say delete that namespace, and there's also a short form for that. So NS means the same as namespace. I'm just basically a little bit lazy, but you can see here the default namespace cannot be deleted. You can also see some other namespaces here. Those are the ones needed by cluster components of Kubernetes. So if you're not a Kubernetes administrator, you will usually not have to look into those much. But ultimately, this is more a section for having a look at the components provided by the cluster itself. So if you're trying to become a CKA, so a certified administrator, this will become far more important to you. But as of now, this is not really important, nor do you likely have the permissions as a application developer to even mess around with those namespaces. But just to show you some of the pods that are running here, you'll actually see them, I should say -n to spell out, give me the pods inside of the kube system namespace. You can see here etcd runs inside of it. The scheduler cluster component runs inside of it, the API server. This is all out of scope for the CKAD certification. But if you're thinking about potentially taking the CKA, that is an aspect that you will have to become familiar with. All right, so I mentioned those kinds of things. If you do want to interact with the specific namespace, there's the long form option or the short form option. So either -- namespace or -n. I got so used to the short form options simply because of the test as well, that I usually rarely use those long form options anymore, simply because there's more to type, but they do the same thing. Now we can create our own namespaces if we want to, and we would do so using the imperative create namespace command, or by again pointing it to a declarative representation of the namespace, which I have not shown as of now. Let me show you one example here. Looks pretty simplistic, at least with a bare bones namespace definition. There are more options that you can specify here, but this one basically just spells out a name. So here we would create a new namespace with the name Kubernetes. And one more side note here on the namespace, and that is a reoccurring scheme that you will see a little bit later. The namespace acts as a parent object for other objects. So as I said before, the namespace can contain other objects like pods, deployment objects, services, and so on. If we were to delete a namespace, this will basically cascade delete all the objects contained inside of that namespace. So therefore, be aware that if you delete a namespace, it will automatically delete everything inside of it. Just as a side note. Okay, with that, we'll want to jump into the next exercise, which will be number 2 here. And this will give you plenty of exposure to basically creating your own pod. I will keep that open here and we'll make it maybe 10 to 12 minutes. You will actually notice that I will lead you down the wrong path on purpose. So don't be confused if the pod renders an error status message. That is on purpose because I want you to basically mess around with it, find out what the root cause is and those kinds of things. So for this one, I will give you 12 minutes and then we'll reconvene and have a look at the solution. All right, so let's have a look here. So we will go to number 2. So just so you know where we are. And then we will first have a look at the existing namespaces. Right now, we only have the default namespace, but we want to create a new one here. So I will go ahead and create this one using the imperative approach. But you always have 2 different options, declarative or imperative. And you can see here right now, it had been created. Somebody was asking before, how do I render the YAML representation of the namespace in here? And we can definitely do so using the following command. So here I say, give me the representation of that object in YAML. And you can see here that is how it basically looks like. So we have the name here. We have a, yeah, that's pretty much it. Everything else has been populated by Kubernetes itself. And then within the namespace, we now want to create a new pod. So I will say krun, my pod. And it looks like I still have that in my history. And let's go ahead. You can see I'm creating this specifically in this namespace. And now if I were to say kget pods, you will see there's no pod found because that will usually look at the default namespace. I want to find out about the namespace, about the objects in the namespace CKAD prep. That is exactly where you would find it by spelling out that namespace. Now you can see here in this case that we actually do have an issue with pulling the container image from Docker Hub, which is the default registry. And for that, let's have a quick look at Docker Hub here to see what's going on. So we can basically go back here and search for the corresponding image. In this case, that would be Nginx. So we can click on that. And when you click on tags here, you should be able to find that specific tag, but at the moment it likely doesn't exist. As you can see here, I led you down the wrong path. Ultimately, just to show you what would actually happen if we select a tag that does not exist, we can decide to use something different. And let me just use one that I saw here in the overview. So for example, let's say we want to use 129.4. We can definitely change my definition of the pod. And before I do that, let me set my kube editor, which is the environment variable. It lets you set a specific editor for the kube control edit command. So we can say KEdit or kube control edit. And we want to edit the pod, my pod. And what we'll get here is the runtime representation of that object, which we can even further modify. So you can go in here. We don't necessarily have to delete the object in the first place. We can modify that runtime representation and say, I actually want to use a different tag here now. All I need to do is to save it. And then if I were to have a look at the existing pods again, after a while, Kubernetes will run its reconciliation loop, which will then try to look for the change configuration and will then rectify that state within the object that I modified here. Now you can see here right now, I have my pod running. It runs 1 out of 1 containers. So everything seems to be good in the first place. You can definitely also inspect the object using the describe command. Oops. Describe pod. And the name of the pod here is my pod. And that would basically be that textual representation that I mentioned before, including the IP address that we talked about earlier. So we can talk to this pod using this IP address if you want to. Side note, also have a look at the events section. That is a section that records messages when we start up the containers. And this is super useful if you want to identify any kind of error messages that give you more detail on what may have failed in a starting pod. And now what I want to do here is to basically make a quick call to that pod just to show you how this works. So I can use a temporary pod, as you can see here. I don't want to run this in a dedicated namespace. It can run, for example, in the default namespace, so a different one than the one we created. And I can still use the same IP address. Oops, I copy pasted the wrong thing here. So let me correct that. We'll go back here, krun temp. I will remove this. Hopefully you can read this right now. I will basically scroll up a little bit soon. And simply run a curl command against that IP address of the other pod. And what we should find here is that we get a response from that pod, in this case, Nginx. You can see here at the end, it will also tell us that the temporary pod has been deleted afterwards. So even though we ran this pod in the default namespace, it made a jump over to a different namespace. The IP address will always be unique, and it will be accessible from pretty much any pod within the whole Kubernetes cluster. Now we can also use the exec command. Well, let's have a look at the logs command first. And you will see a bunch of messages that have been created by the Nginx process. You can actually see I made a call to it, and this is being logged here as well. I can use the exec command, and let's make it an interactive call. So here I just want to say my pod. I want to open this shell here, inside of here, I can, for example, have a look at the list of processes if that command line tool would be available. It's not. But for example, I could say, who am I? Who am I? I'm probably the root user. I can probably get the current path here. I'm currently in the current directory, the root directory. You can see I can navigate the temporary file system of that container if we wanted to. Something we won't do, but this is super useful for troubleshooting purposes. So if you want to leave that interactive shell, simply just type exit and you will get out of it. And then lastly, one more thing I want to show you here is the delete command. So delete command here would effectively not only delete the namespace, so if I list my namespaces again, oh, sorry, this will actually delete the pod inside of the namespace. If I wanted to delete the namespace, I can. And that would have deleted the pod inside of it as well. Something you can try out on your end. So here's the question: how did it jump to a new namespace? I'm not quite sure how you got from namespaces sacred and what exactly you mean by that. Pretty much teams and anyone else can basically create their own namespaces. So anyone usually has the permissions to do that. And as the admin of the Kubernetes cluster, you will usually want to provide those namespaces to teams. You can always operate in a different namespace by using this command line flag here. I didn't necessarily jump over to a different namespace. I just said this command should basically run or should operate against a specific namespace. And that is basically how you do it. So here's the question: can we reach the Nginx pod without creating a temporary pod? You cannot, simply because I'm running on a different host machine here, and Minikube or the cluster itself is effectively, sorry, I forgot what I wanted to say. So basically, I'm running Minikube, and Minikube is running in a virtual machine. And therefore, you cannot create it. If you want to, we could basically try this. So if I were to just want to create, say this one here, I'll just create a temporary pod, but without the --rm option. In the default namespace, KGet pods. This one apparently is failing. Okay, but it still has a IP address, which I can describe. And you will see if we were to run the curl command here. So if I use this one, clear, curl from my local machine, you will not be able to reach it. So this IP address is not visible from outside of your Kubernetes cluster. All right. Here's one more comment about having moved pods. So far, we didn't move pods. Basically, pods are not movable in that sense. So if you wanted to create a pod in a different namespace, I'm not sure if it would allow you to change that. So if I were to say here, for example, edit pod, I don't have a namespace. Let's say I wanted to do this. And I want to place this into a different namespace. I'm not sure if it would allow me to do it. I'll probably have to delete the object first and then see. You can see that the option here is not available by editing the live object. You basically have to delete the object and then effectively create it in a different one. So let's see what other questions there were. So can I access the Nginx server in a pod on a different namespace? Yeah, that's exactly what we've actually done. So any pod is available from any other pod in the Kubernetes cluster, independent of which namespace it lives in. at least from the perspective of the IP address. And here's one more question. How do we remove apps or kill apps, I guess, inside of the container? I'll give you a short and a long answer. So the short answer is you can open an interactive shell and delete the process from the process list. You can delete it there if that's what you want to do. Long answer is you will never want to modify running processes necessarily inside of your containers if you want to modify the configuration of that pod. And the reason why you don't want to do it is for security reasons. If you find that a running process is not suitable to your application or whatever you're doing, then you would usually want to rebuild a container image and change that configuration in general. And here's one more question on the O'Reilly sandbox. Again, O'Reilly sandbox does not have that container image available. So you will have to basically create it in the O'Reilly sandbox even, which may not even have Docker installed. That I don't know. So the Node.js Hello World container image we build locally. And that means if you were to try to create a pod, from that container image, it does not exist. So you have to run the Docker build command first. Because this container image does not exist on any of the Docker Hub registries. I can come back to you, but maybe you're misunderstanding what we actually did here. I would actually suggest if you're struggling with creating containers, this is not necessarily the right course to jump in. If you're not familiar with containers whatsoever, take a different course on the O'Reilly platform, because we don't necessarily have time to go back and talk about the very basics. All right, any more questions on the pod and namespace Kubernetes primitive? If not, I think we'll take another 5 minutes of a break, and then we'll basically transition over to the next topic, which is going to be on jobs and cron jobs. So different use cases for wanting to run workload. But just as a little summary here, exam essentials, what do you need to understand for the exam? So be familiar with how we can create pods either imperatively or declaratively. There's not going to be a strong guidance on which approach to use. You can use either one of them in the test environment. Be familiar with the most basic commands that we've been using, like the get command, create command, delete command, and the commands for inspecting the object. And then also, and we'll dive into that a little bit more deeply later, is understand, or at least have an initial understanding, how to diagnose issues for pods based on their error conditions and how to troubleshoot those issues in more detail. But we'll talk about troubleshooting scenarios in more detail a bit later. For now, just be aware that there could be an error status message for a pod which will potentially indicate an issue. We've also had a look at the different namespaces, and the namespace default does exist by default, cannot be deleted, but you would usually want to place your object into custom namespaces. All right, so I would say let's take a 5-minute break and then we'll get right back to it. All right, so we have about an hour left for today. So we definitely do want to spend some additional time on talking about jobs and cron jobs and optimally the volume concept. And the first topic we want to talk about here are the jobs and the cron jobs. Why do we need them and how can we basically manage them? So before we basically ran an application, but under certain conditions, we may want to run other kinds of operations inside of pods. And that, for example, could be something that is considered to be a one-time operation, which would be represented using a job. So for example, you could imagine you have an application running inside of a pod, but then maybe you want to import or export some data produced by that application. And that is simply a one-time operation. Once that process is done with, we don't want to run that pod anymore that was responsible for copying those files. And therefore, we can simply remove it. And that would be a good use case for a job in general. We could also have a so-called cron job, which is similar to a Unix cron job, so it runs periodically. So for example, you may want to create a backup nightly or something like that. That could be use case for wanting to use that kind of primitive. So let's get started by talking about a job. So I already mentioned the general use case for such a one-time operation. We can definitely configure the job to basically run multiple times if we want to. That is a configuration option. So for example, if you want to achieve something multiple times, but it would be a one-time process operation in general. You can think of the job as a higher level managing instance for a pod that should run the operation itself. And I think it's probably better explained by a little visualization here. So you can see here we can create a object of type job, and the job will then automatically create a pod for us, which will then run that import-export process that we want to perform. Now you can see here that we're actually running two different pods, and it is one of the configuration options that we have with a job. We can decide to run things in parallel if we want to split up workload, for example. Let's say you have a big data set and you want to split up the data into different charts. That could be an option that we can choose from, but ultimately, by default, one job would create or manage one single pod. It's not necessary that you create multiple different kinds of pods, but it is definitely one of the options. One more side note here. Again, we have a higher level instance similar to what we've seen with the namespace. So if we create a job, it will manage the pod objects for us automatically. If you were to delete the job, it will automatically delete the pods that it ran automatically for you as well. You will actually see that the creation of a job is not very different from creating a pod from scratch. If you actually at least look from it from the perspective of the imperative command, there's a dedicated imperative command called create job, which lets you, again, spell out a container image and then potentially a command that you want to run inside of that image. Now, the command that you're running here is optional. It could also come with the container image already. So once you create a job, it will create the pod for you, which will run as the one-time operation. Now, we went with a whole bunch of different default options for running that job. If you crack open the definition of the job, you will actually notice that there are far more configuration options that I mentioned before. For example, do I want to run multiple pods in parallel? What should happen if we run into an issue? Should we fail at some point of time? How many times do we want to run the process? Those are all configuration options that you have available. You don't necessarily need to understand all of those here, but generally speaking, be aware of them because they may come up as one of the asks within the task of the test environment to simply just set it so you kind of know where to set it, but you can definitely find plenty of information about that even during the exam, if you look for the job definition in the documentation. So if you scroll down here a bit, you will see it will mention all of those options here. So if they ask for a specific kind of configuration, you can always look it up directly here in the documentation. And just to outline here that we can create the job and the job will automatically create the pod. That is exactly what's happening here. So in the beginning, I created a new job. You can see completions is 0 out of 1. And then later on, you can see that the job actually ran the operation. So therefore, it completed the one-time operation. And if you look at it from the perspective of a pod, you will see there's a pod that is in the status completed or failed potentially. In this case, it's actually completed because the process that we ran, for example, import, export, exporting data, will simply just finish at some point, and therefore the container is not running anymore. Just be aware that the job will keep the pod around. It will not automatically delete it. That is something that you proactively have to do on your end. And then similar to inspecting pods or containers inside of pods before, we can run the logs command. And there are different operation types, which I will probably not go into too much detail. But ultimately here, you can see there are different options if you want to run it in parallel or not, how many times you want this to happen. And as a result, you can get a specific kind of job operation type. I will not go into too much detail, but you can definitely read up on it in the official documentation. Now, there's also an attribute called backoff limit. That is a attribute that lets you define what should happen or when should be marked the pod as failed. After how many attempts do we want to mark a pod as failed? Because imagine a certain process running could have some failures, but we can configure it to try it multiple times before it actually gives up. And then lastly, there's also the restart policy, which will determine if the container needs to be restarted, yes or no. So that's something that you can look up internally in the documentation at some point. All right, so I would say we'll give this a try. This should be relatively easy, but I want you to see what actually happens when we create a job instance. You will see that we'll create a pod for you. We don't have to create the pod or manage the pod on our end. That is something that you can do by simply creating the job. And for this one, maybe just 10 minutes, and then we'll reconvene after the timer runs out. All right, so let's have a brief look here at the solution. I'll keep it relatively short. We'll go to number 3. And what I would usually do for a job, I will usually go to the documentation here and use this as a starting point. So this one you could probably use and simply just say job.yaml. I will then paste it into here and then further modify it. You may have seen that for this one, we needed to do a couple of modifications. So for example, the name would be different. This will definitely take me a little bit of time to basically iron out now, random hash. But that is also the technique that you could use in the exam itself. You can see some of the configuration options were different. And then down here, we wanted to use a different container image, random hash. And here we want to use Alpine 317.3. I believe this should also be different. So let me just get that from my solution here. I can see I already have the backup limit down there configured, so we'll have to take it out in one location. Just take it out down here. Okay, and the restart policy, I've copied the wrong thing. Just give me one sec. is this command. So effectively, whenever we spawn a new pod, we would generate a random string, and then this random string should be base64 encoded, and I believe it should only have 20 characters. Let's have a look at this one. So what we would do, we would create the object from it, in this case, declaratively. Okay, so we created the job in the default namespace, and we can definitely have a look at the jobs and the pods right now. By the way, you can basically concatenate multiple Kubernetes primitive names, as you can see here, and render both of them to the output. We configured this one to have 5 completions, and you can see at the moment there are 4 out of 5 completions available. If I were to run this again, we would probably see that all the 5 completions running in their own pods have completed. And you can see they're all still here. They're not deleted automatically. One of the reasons why that is simply because we want to keep them around for troubleshooting purposes, or potentially you may want to have a look at the logs. We could say the following. So give me the logs for this one, and we should see this random string here. And yeah, that's what we wanted to do. So it's relatively straightforward to get this right in the certification. It scores you some easy points. Also want to make sure that I show you the configuration, or show you what happens when we run the delete command, and it will effectively delete the job as well. The job has been deleted. So if I run the command here again, jobs and pods, you will see not only has the job been deleted, but also the pods that were managed by that job in more detail. All right, any more questions on the job configuration? Now, the next topic is going to be on the cron job, and you will actually see that the cron job is not super different from the job. All right, I see no questions right now. So generally speaking, a cron is similar to a job. It's its own Kubernetes primitive, but it will basically delegate towards a job instance automatically, and it will basically create that job instance based on the cron expression that you provide upon creating this cron job. So for example, you could use the same notation that you know from Unix cron jobs and assign those to the definition of the cron job, which will then indicate to the job when to create the new jobs. So for example, we could say we want a operation to happen nightly, every hour, every 5 minutes. So depending on what you want to achieve here. Let me show you the overview of the visualization again of those objects. So you would be in charge of creating the job. The job, cron job, sorry. The cron job would automatically create the job, and then depending on the configuration of that job, it would basically spawn those pods for you. Now, on the imperative command side of things, there's one thing I should mention here, which is the schedule. So the schedule is the command line option that lets you define the Unix cron job expression. So the notation exactly the same, nothing new here. And that will basically indicate to the cron job when to run. If you have a look at the definition in the form of a YAML manifest, you can see that the schedule is directly organized underneath the spec section. And then in the spec section, you will also find the template for the job to be created by that cron job. So that definition is pretty much the same as what we've seen for the job definition. So nothing new. It simply allows you to define the same kind of configuration options, but ultimately just want to show you one bigger example in the context of one YAML file. So once we create the cron job object, you will see that it will spawn those jobs depending on the cron job expression. In this case, in this example here, I configured it to run every minute. And you can see every minute it will create a new job object, which then will create its own pods to run the operation. Now, the amount of jobs that you will want to keep around historically can be configured. By default, it keeps around 3 successful jobs and 1 failed job. But if you want to see more failed jobs or less successful jobs historically, you can reconfigure that by the command line, by the options in the YAML manifest called successful job history limit and failed jobs history limit. So those are completely configurable. I would say do this one at home. It's somewhat similar to what we've done with the job already. So I think you'll probably not learn too much new here. So give this a try to branch out a little bit, but ultimately this will look fairly similar to the job definition. So for the exam, you need to understand job and cron job, how to configure them and how to operate them. And I think one of the most important things about them is that they have this parent-child relationship. So if you delete the parent, or create a new parent, it will automatically create those children for you. All right, any more questions on the jobs and cron jobs? And I will want to spend the remaining 30 minutes on the topic of volumes. Here we want to talk about ephemeral and persistent storage for pods in general. So I'll just give you a couple of seconds to think about it. If there are no additional questions on jobs and cron jobs, that's awesome. And we'll simply just move on. But I think volumes also is a fairly important topic. Let's see if we can actually finish both exercises in this realm. If not, we'll definitely discuss at the beginning of the course tomorrow morning. All right, I see no questions. I would say let's talk about what volumes are and why we want to have them. I mentioned before, and we've actually seen this when we created the pod and opened an interactive shell into the running container, is that we can navigate the file system of that container, which is usually called the root file system or the temporary file system, simply because the data written to that file system is not persisted over time. So if you restart the pod, or if you delete the pod, or if there's some maintenance going on in your Kubernetes cluster, this data will simply be lost. So anytime the container is restarted or like deleted in any kind of form, that data is simply gone. But there are definitely some use cases where we will want to have a different kind of runtime behavior for data that we want to write to or from a container. I mentioned earlier that we can define multiple containers in a single pod, and we'll get to that pretty soon. However, when we talk about the file system that comes with one container, it's always going to be just isolated to that one single container. So if you do have the need to exchange data between multiple containers running in the same pod, you cannot simply do it with the built-in capabilities of a container. And that is effectively where the volume, and more specifically, the ephemeral volume comes into play. So the ephemeral volume is a volume that lets you read or write, or both operations, run both operations, and exchange data between multiple containers. So if you have the use case for wanting to cache data, maybe some caching functionality tries to read to the file system, write to the file system, and you want to read from it, or if one container wants to tap into the same data as the application container, those are use cases where you will probably want to go with the ephemeral volumes. Keep in mind, ephemeral volumes will not persist the data either. They are only meant for data that is not super important, that you are willing to lose, that lets you exchange data between multiple containers. So therefore, the use case is somewhat limited. But as soon as we talk about applications that are either data-driven or that write to the file system, and you definitely do not want to lose that data, independent of a restart of the container or cluster. In those cases, you will probably want to go for the persistent volumes. So persistent volumes let you preserve the data beyond the lifespan of a pod. But independent on whether it's going to be restarted or not, or deleted, the data will still stay there. There are a couple of options that we need to look into when we want to define either a ephemeral volume or a persistent volume. And that is the definition of the volume within the pod, and then the consumption of that volume from within one or many containers inside of that pod. And those options are basically spec.volumes, and then the mounting or the mount path will be defined using spec, the specific container, and then a volume mount for that container. Now, there are different types of volumes that we have available in Kubernetes. And the ones that you see here on the slide are not the only ones for sure. There are plenty of other volume types you can choose from. I would say of all the volume types that you see here, those are going to be relevant potentially to the exam. But there are other ones that I won't even necessarily mention. One of the ephemeral volume types is called mtdir. And based on that file name, based on that volume type name, you can probably guess what it does. It simply provides you with an empty directory that has read and write access, by default at least. You can configure it to only have a read access, for example, and no write access. And therefore, that is a configurable option. But ultimately, this is only available for the lifespan of a single pod. Now, if you ever looked into the configuration of cluster component pods, so for example, the configuration of an API server or etcd, you will notice that they will likely just write to the underlying host that the node runs on. So for example, if you want to persist the data for etcd, for example, it will always run on a specific control plane node. And therefore, if you want to write it to the underlying host, you can use the host path volume type. Then we have the option to inject configuration data as files or a mounted volume. That is something we'll talk about probably more tomorrow. But there we have the option of config map and secret. You can mount a network file system with the NFS volume type option. And then lastly, for persistent volumes, there will be the option of persistent volume claim. Now let's first talk about the ephemeral volumes. I mentioned before, the root file system that comes with the container is part of the container itself. It cannot be shared across multiple containers, so therefore it's isolated for that single container. But if we do want to exchange data, for example, you want to run a sidecar, and I will explain what that is a bit later, then you can exchange data between the application container and the sidecar container using such a ephemeral volume. And that basically defines that volume outside of the context of a single container and makes it shareable. Now, just to show you those configuration options in the context of a pod definition, I can see under volumes, there's the definition of one single volume. This one is of type mtdir. And you can see those little curly braces. Basically, what that means is simply just go with the default configuration of that volume type. Don't add any additional custom configuration. That would be where you can basically configure it to be read-only, for example. But for now, that's actually not where you define it, read-only. That would be in the volume mount. But here you can basically restrict the size of data we want to write as a maximum. That could be something that we can configure for mtdir. But the curly braces basically here means simply just go with the default configuration. And then underneath the container definition, you will actually find the path that we want to make available from within the container that will then let us read and write data. So in this case, we want to allow reading and writing data from var logs. Now, once we create the pod, you should be able to navigate excuse me, you will be able to navigate to that location, to that mount path, which is var logs, and write and read data from that location. So it becomes available if you exec into that container. And with that, we'll actually want to give it a try. This would be exercise number 5. And what we want to do here is to basically run Nginx again inside of a pod. But inside of here, you may know that Nginx needs certain file paths to be available. And those we will make available using the volume definition. So I'll give this maybe 10 minutes, and then we'll reconvene and have a look at it. All right, so let's have a look at the solution of exercise number 5. I don't think we'll get to number 6 anymore today. So what we'll do is to talk through the solution. If you have any additional questions, feel free to already ask them in the attendees chat or the Q&A section, and then we'll arrange for some additional time to answer them. And then tomorrow, we'll start with the persistent volume, how that is different from the ephemeral volumes, and how to configure them. All right, so here we wanted to define a ephemeral volume. And what I'm going to do, I'm going to use a starting point from the solution. So the starting point is simply just a pod definition. So by now you can see we've done this a couple of times already. But here we want to define, first of all, the list of volumes. And of those volumes, we want to have 3 different ones. Each of those volumes have a name, and they have a type, and the type here is empty dir, curly braces here. And then we can duplicate that multiple times, because we want to define not only a single volume, but multiple. So this one will be called data, and this one will be called cache. And then within the container definition, we will have a volume mounts section. And in here, we'll have 3 different volume mounts. One for Nginx run, which uses the mount path var run. And then we have 2 more, which I'm just going to copy paste from the solution. I don't have to type it all. Which point to different directories within the container. Now, there was one additional comment or question that I left here, which is on basically a security concern. So let's say we have an application, which is the case here, that wants to write data, but we want to lock down the root file system that comes with the container itself for security reasons, so that a attacker that potentially gains access to the root file system cannot install any malicious software anymore. For that purpose, we can basically set a security option. And this is just an outlook basically to a later discussion on security options here. We can set the security context. That is a attribute that we can use within the pod definition to effectively set one of those attributes here. You can see I'm setting the root file system to true, and therefore lock down that temporary file system so that any attacker or anyone that gains access to it cannot install any additional tooling. So let's go ahead and create the pod from it. And it looks like the pod has an issue, unknown field. So let me go back into my definition. Security context. Okay, so that's a definition that needs to be defined underneath the container section. So we'll just add it here at the end of that. And make sure that the indentation is correct, of course, 2 spaces. Let's create the object. Still not. Volumes is also incorrect. So let's see what I did here. So that needs to have 1, 2. And I think that should do it. You can see that's completely to be expected. Now the namespace doesn't exist. So let's create that first. H92. And then we should be able to create that pod without any problems. -n H92. You can see currently in the process of being created, and it's running right now. Now that it's running, we can exec into the pod. This one was called Nginx in the namespace H92. And then, for example, if you look at the volume mount here, var/run, you should be able to see that Nginx actually wrote something to this. So that's the proof that that is happening, but it's not happening anymore in the root file system of the container itself. Let's say I'll go back here to my root directory and now try to create a new file. You can see that by setting the security context option, it does not allow me to write any more files. So therefore, we locked down that behavior. And that is really all we wanted to do in this exercise. So I think that was probably pretty straightforward. So we have about 5 minutes left in the course for today. Do you have any more questions you would like to address for today? If not, I can let you go a couple of minutes earlier, not too long, but not too much earlier, but ultimately just wanted to give us some room, some time to address any of your questions that you may have. And then tomorrow, what we're going to talk about is the next bigger section. So we'll finish with persistent volumes, but then we'll transition over to the more advanced deployment primitive, which we'll likely use primarily in production environments to actually run our applications. So I think that's going to be exciting. There we will already talk about deployment strategies and why scalability is important. So I think we'll expand on what we learned today by bringing it into the real world even more strongly. All right, I see no questions at the moment. So all I got to say for today is thank you so much for joining today. And hopefully I can see you tomorrow in session for day number 2. And with that, I'll give it back to Brittany, and I will see you tomorrow. Hopefully you have a good day and see you soon.
All right, thank you so much, Benjamin, and everyone who participated in today's course. This concludes day 1. We will see everyone tomorrow for day 2 at the same time of 7 a.m. Pacific. Enjoy the rest of your day. Goodbye, everyone.